that with 9.1, it is probability distribution and expected values. Okay, so very first thing with it is a probability distribution. Is basically it's just a table of probabilities. It's a table of events and probabilities. So it's a table of events and probabilities of each event. Okay, when you're going through these, the sum has the total, when they give you all the events for this one and all the probabilities, the sum of all the probabilities has got to equal 1. That if you're going, so they're giving you this distribution event and saying, all right, here's all the possibilities of what's happening. So when you find the sum of all the probabilities of this table that you have, it's got to add up to 1. You cannot have any negative probabilities. Because that just doesn't make any sense. It's something, it's a negative. It's a less than 0% chance of something happening, so that won't have that part. And the other thing they're going to talk about, which is the last part there, is the expected value. And basically, the expected value, it's the sum of each event times the probability of the event happening. Okay, so probability distribution is just a table of events and the probabilities that go with each of those events. The sum of all the probabilities put back together has to equal 1. You cannot have negative probabilities. And the expected value is basically what it comes down to is they're going to ask for, if you spin a spinner or you roll a dice or whatever, and these are your events, what are you probably going to get is what it comes down to for something like that. So let me give you some examples. And so that's all the notes. That's all that. There's not really any particular formula. Is really it's just kind of, this is your expected value formula. And we'll show you a couple of examples that would go with this. Okay, so the very first one may be something like this, where that you've got x and then p of x, and let's say it's 2, 3, 4, 5. So your possibility, your events happening were 2, 3, 4, or 5, and your probabilities are going to be 0.2, 0.1, 0.3, and 0.4. So just a small little table of events here, and they're going to ask you, all right, what's the expected value? Okay, so what you're going to do when they talk about the expected value is you're basically going to take the probability that you have of getting a 2, which is 0.2, and you're going to multiply these two numbers together. So it's 0.2 times 2, and then you're going to add that to the same thing with the next event. If getting a 3 is a 0.1 or 10% chance here, we're going to multiply those two things together, and then just keep going down the row. Do your 0.3 times 4, and then do your 0.4 times 5. Okay, and then just run all that through, punch it in the calculator, see what number you get. And I forgot to write this one down, so let's see. Running through those numbers real quick. Should come out to be a 3.9 because this would be 0.4, 0.3. This would be 1.2 and 2. So if you add all that together, it comes out to be a 3.9. Okay, which if you look at the numbers, you've got a higher probability of getting a 4 and a 5. You got a lower probability of getting a 2 and a 3. So that's gonna, where normally if it was dead, and if these were all equal, we'd have like a 3.5 in the middle. But since the 4 and 5 are higher probability of getting those two, it's going to scoot that number a little higher up to the side of the 4 and the 5. So that's where we get the 3.9 from. Okay. Now they will also do the same thing on a histogram. And when they talk about a histogram, that's just a bar graph. It's just a special kind of bar. They don't call it a bar graph because it's the bars aren't connected. It's basically a bar graph is really what it is. It's just a different type of a bar graph. But when you do that probability distribution, it's basically the same setup. It's just not in a chart. It's not in a table like this. It's just in a bar graph, or what they call a histogram. So that will look something like this. Too far there. Okay, and this one probably should have been a little bit taller, more like that. Okay, so here's one where they give you a histogram, and same thing. They still talk about the expected values that you would get from this one, and we'll do the same thing here. So here's your chance of getting a 1, 2, 3, 4, 5 this time, and we're going to do the exact same thing. Is we're going to multiply, the chance of getting a 1 times the probability, which would be 0.1. Do the same thing for a 2, which would be a 0.2. 3 in that case is a 0.15 because it's halfway between 0.1 and 1.2. Getting a 4, that one is at a 0.25. And then getting a 5, that would put us up there at 0.3. Okay, and then go back and put all those numbers together. And doing that, you should get a 3.45 for the expected value. Okay. And same thing if it was just a regular number, 5 numbers on a spinner. If you spun it around with all equal chances, 3 would be in the middle. But because if you look at this one, we got a little bit higher chance of getting 4s and 5s. It kind of pushes it out that way just a little bit. So. Okay. And then from there, they've given you the tables. After that, they kind of just give you some word problems. And from those word problems, you either have to kind of go back and put it in a chart, or you don't really have to make a chart from it. They may tell you to, but really it's mostly just figuring out what the probabilities would be when it comes off of it. One, if that was this is the example 2 back up here. Sorry. For example 3, we're going to look at a roulette wheel. And with a roulette wheel, you have 18 red, 18 black, and then you have 2 that's, we'll just say it's not red or it's black. It could be green, it could be white. It doesn't really matter what it is in this case if we're going away from it. Basically, we've got 18 red, 18 black, and 2 that's not red or not black. Okay, and for this problem, they're going to tell you that for these types of problems that, if you're going to do this, you're going to have to put a $15 bet down. So let's say if you place a $15 bet on red, you would get your $15 back and make another 15. Everything else that's not red you lose your money. All right, and they're going to ask you, all right, find the expected payback. For a $15 bet on red. Okay. I probably should have had this one printed off and made this one a little bit easier. So, all right. So we got a roulette wheel, 18 red, 18 black, and you've got 2 that's, best I can remember, I think they're green. So maybe one's green and one's white, where it's kind of neutral on those. But anyway, 18 red, 18 black, and then 2 that's non-red or non-black. So the setup on this one is you've got to know that for this part of it, the way they look at it is that just kind of put a chart down here. That basically we're looking at that if we have this thing, we're looking at red as being a winner, and anything else is going to be a loser. So if you want to kind of make a table for this one, you can kind of do that one. All right. Now, the way they kind of look at this one is that even though you're putting $15 down and you're getting your 15 back, that basically you're doubling your money. If you get 15, you get $30 back. They want to know how much money you would actually make. So when you put the $15 down on red, you actually are only going to make the $15 because you get your $15 back and then you get $15 more for that one. Anything that's not red, you're losing your $15. So you're actually going in the hole and losing your $15. So anything red, you make 15. Anything that's not red, you're going to lose 15. And then you just have to kind of put your probabilities of those that's here. Well, if you go back up to the top up here, there's 38 different slots because you got 18, 18, 2, so 38. Of those, if we're going to do red, that's 18 out of 38 that's red. And then that's 20 out of 38 that's not red. Now, of course, those aren't in simplest formula, but they're going to ask you, in this case, where we're talking about money, you're going to put it in decimal form. So all you're going to do is, once you've got this kind of set up, is you're just going to multiply 15 times 18 over 38. And that comes out to be 7.10526. And you've got a bunch of decimals after that. And leave that in there as long as you want to when you do that. And then go ahead and multiply these two numbers together. So that's 15. And that's a negative 15 times 20 over 38. So this comes out to be a negative 7.8947, and all the numbers after that. And again, leave all those numbers like it is there. Then combine those two things where you don't round any numbers off just yet. You kind of wait till the very end to get there, and then go back and basically just add these two numbers together. So we got 7.10526. Add that to the negative 7.8947. And then once you get your final answer, then you round this one off. This comes out to be negative 0.78947, whatever it is there. So again, with money, you're going to round it off to two decimal places. So that means you're going to lose 79 cents. Okay, so if you're playing the roulette wheel, you're probably just throwing your money away, unless you get lucky. Okay, and one more of those, and that's pretty much all that they can throw at you here in section 9.1. And this would be kind of along those same lines, but a little bit different here. You can put $6 to pick any number from 0 to 499. Now, they can have a giant spinner, they can have whatever it is. So you pick one number between 0 and 499, you put the $6 bet on that. If you win, you get $400. Of course, if you don't pick the number, then you just lose $6. And they're going to ask you, okay, if that's the case, then find the expected return on a $6 bet that you have here. Okay, and similar to the last question, you're not actually winning $400 for this one. You know, you've got to actually pay the $6 to do this. So if you win, you actually are going to make $394 because you got to take out the $6 bet you had. If you lose, well, you've lost $6. You're negative $6 in the hole. Okay, and you're picking one number, and there's only one winner out of this whole thing that's here, so the chances of you winning, that's 1 out of 500. Chances of you losing, well, that's the rest of it. That's the 499 out of 500. And then we'll do the same thing. You'll go ahead and take the 394 and multiply it times 1 over 500. Again, they're going to ask you what's the expected payout. From placing the $6 bet. All right, and you would do the same thing. You would do the 394 times the 1 over 500, which would be 0.788. Do a -6 times this, times the 499 divided by the 500. That comes out to be a -5.988. And we're just going to add those two things together. And again, they're going to tell you to put it in terms of money. So it's going to be a loss, or expected return of -$5.20. Okay, and everything else that's in 9.1 is pretty much going to be that same routine of you're going to figure out, what either it's a table where they give you the table and you just go through and multiply each event times that one, or they give you a word problem where you pretty much just make a small little table and do the same thing to kind of figure out what the events would be there. Okay, and for 9.1, that is all that I have for today. And again, we're going to wait and not do anything else for Chapter 9 because if we move too fast, then we'll have to take some breaks in the middle. So this will kind of space things out a little bit. Any questions y'all have on anything?